In this video, we are going to practice the idea of finding the limiting reactant. So this question says 3.22 moles of solid aluminum react with 4.96 moles of hydrobromic acid to form aluminum bromide and hydrogen gas. So first up, they're asking us to write a balanced chemical reaction. So this is going to be important. You always need the balanced chemical reaction because you need that mole to mole ratio in order to find out what the limiting reactant is. So they said solid aluminum, so I'll write Al solid, plus hydrobromic acid. So going back to our acid nomenclature, that's referring to HBr. So I'll write plus HBr, and they did say it's an acid, so the state of matter is aqueous. And we are forming aluminum bromide. Now, aluminum always makes a 3+ ion, and then the bromide is Br minus. So looking at the periodic table, aluminum is always 3+. It has those 3 valence electrons based on where it's situated. That hopefully that makes sense because it has, it's 3 over. It likes to lose those 3 valence, so it becomes aluminum 3+. And then bromine, being a halogen, it needs only 1 more electron to have a complete outer shell, a full octet. So that's why bromine is always 1-. So if we were going to make a compound, a neutral compound between aluminum and bromine, we would have 3 bromine for just 1 aluminum, so AlBr3, and that's probably going to be a solid. So recalling our solubility rules, all nitrates are soluble, NH4+ ammonium compounds are soluble, and then any of those group 1 metals, those are all soluble. So that doesn't fit any of the rules, so it's probably a solid. And then they said hydrogen gas. Now hydrogen is one of the 7 diatomics, so you write H2 gas. And then next we need to balance it. So I see 1 aluminum each side, which is good, but I see 3 bromine here and only 1 bromine there. So I'll put a 3 in front of HBr. Now in terms of the hydrogen, I have 3 hydrogen on the right side and 3 on the left and 2 on the right. And a common multiple of 2 and 3 is 6. So I'll put a 3 here and then change this to a 6. But now my bromines are out. Now I got 6 bromine on the left, 3 on the right. So I'll put a 2 right here. And if I also put a 2 over with aluminum, now it is balanced. Okay, so next question says, what is the theoretical yield in grams of hydrogen gas? So we need to consider, and there's multiple ways to solve limiting reactant problems if you just have to determine which reactant is the limiting one, which one limits how much product you can make. Now, since they're asking us to figure out the theoretical yield of hydrogen gas in grams, one strategy is we can take the amount of each reactant, so 3.22 moles of aluminum and 4.96 moles of HBr, and convert both of those into grams of hydrogen gas or moles of hydrogen gas. And whichever one gives us the smaller answer, that is our limiting reactant. That is the reactant that effectively limits how much hydrogen gas we can create. So first we'll do that process with aluminum. So I have the 3.22 moles of aluminum, and we'll go ahead and convert both of these to moles of hydrogen gas and then just take the smaller answer and convert it into grams to answer the question. Now, anytime you want to convert from moles of substance A to moles of substance B, you need to use the mole to mole ratio. So for aluminum to hydrogen, for every 2 moles of aluminum that react, 3 moles of H2 gas are produced. So 3.22 divided by 2 times 3, just doing it on my calculator right now, I get 4.83 moles of H2 gas would be produced from the 3.22 moles of aluminum, assuming that the other reactant, the HBr, was in excess. So now let's do it again, but from the HBr's perspective. So 4.96 moles of HBr. We're going to convert this into moles of hydrogen gas. And the ratio for every 6 moles of HBr that react, 3 moles of H2 will be produced. So doing that on our calculator, 4.96 divided by 6 times 3, we should get 2.48 moles of H2. So if the HBr was limiting and aluminum was in excess, then we make 2.48. So which one's smaller? From the aluminum, we got 4.83. HBr, we got 2.48. So the 2.48 is obviously smaller. So that we're going to convert into grams to actually answer the question, the theoretical yield of hydrogen gas in grams. So 2.48, and I'm going to run out of room. I'll do it down here. 2.48 moles of H2. If we want to convert it into grams of H2, we need to multiply by the molar mass, which is 2.01 about grams of H2 per mole. So moles cancels, and we should get 4.96 grams of H2. So that's how many grams of hydrogen gas we would make, because HBr was our limiting reactant. So which was the limiting reactant? HBr. So then that means the other one was in excess. We had more than enough of the aluminum. Aluminum was in excess.